In the last video, we learned that clay and silt settle to form mudflats by process of flocculation. Hi, this is Tanu and welcome to my channel, Mother of Knowledge. To understand flocculation, let us recollect the formation of mudflat.
Have a mudflat, and what we call an intertidal mudflat needs to develop. Okay. These tend to develop maybe on the edge of estuaries, like we can see in this photo here, where we've got a river meeting the sea, and on the edge of that estuary we've got this collection of very fine clay and mud sediment that's built up. Okay. These tend to develop maybe on the edge of estuaries. The sediment here is very, very fine, and that's because maybe the rivers have carried some of that very fine clay and mud down into the sea, or maybe tidal currents that have washed over this part of the estuary have also been transporting some of that very fine sediment as well. They tend to be found in river estuaries and other sheltered areas, particularly perhaps areas behind a spit as well. So salt marshes and mudflats, we can very much associate those with being connected with spits and bars and tombolos. There's a number of reasons why deposition is so prevalent in an estuary, and one of those reasons is because of the interaction of the sea and the river. Okay, so the outgoing river and incoming tides both carry lots of fine sediment with them. So we have the situation where a river with lots of sediment is going in one direction, and tidal currents carrying sediment are coming in the other direction. So we've got a large input of sediment into this area. Another important process is the interaction of the salt water from the sea and the fresh water from the river. What happens as a result of this is a process called flocculation. More about that in a minute. But what happens as a result of flocculation is that the salt in the seawater causes the clay particles, which might be floating around in the water, to stick together and therefore become heavier and ultimately sink and settle to the bottom and be deposited.
What you are looking at in this footage is freshwater meeting seawater. This is where the freshwater of the river, which is full of silt, meets the denser clear blue salt water of the ocean, making it look like there are two separate bodies of water not mixing. Now, it may appear like the freshwater is pushing back the seawater and creating this boundary between the two waters, but that's not the case. The two waters are mixing, it just doesn't look like it. When the freshwater crosses the boundary to become salt water, it suddenly becomes very clear, which is why the boundary seems to exist between the dirty and clear waters. The brown murkiness of the river water is suspended sediments, which are silts and clays carried by the fresh water. However, salt ions in the seawater bind to suspended particles and cause them to stick together, causing them to become heavier and sink to the bottom of the ocean, making the water become clear. So where it may appear like an impenetrable boundary between two distinct bodies of water, it's actually a very sharply defined mixing zone. The lighter fresh water rises up and over the denser salt water, creating a boundary under the surface, where the particles are binding together and dropping down, forming a sediment layer, and mixing the two waters together.
Both of these factors, the large amount of very fine sediment and the interaction of the salt and fresh water, means that deposition is happening very rapidly in these sorts of environments. That's obviously amplified again by the fact that these areas are quite sheltered, and therefore the sediment isn't being carried away by strong waves or other currents. To say a little bit more about this process of flocculation, you can see it happening actually in this little experiment, which you've got 3 photographs of on the screen. So initially we might have this situation here where we have lots of suspended sediment. Okay? These tiny particles of clay are so small that no matter how still the water is, they aren't deposited, they aren't heavy enough to sink. On their own, they will always be carried in suspension. That's what gives the water this kind of cloudy appearance here. It's because there are very, very fine particles which are floating around in the water. Okay. What happens as the salt water and the fresh water meet? The salt within the seawater basically gives an electrostatic charge to the clay particles. So if you imagine for a moment that we have lots of clay particles floating around in this water, I'm just going to draw them much bigger than they actually are in reality. Lots of clay particles floating around in that water. The salt gives those particles an electrostatic charge. It basically means that they are attracted to each other. Okay, so what will happen is that all of those clay particles will be attracted together. They will clump together, and that's what we can see happening in this middle photo here. We can see that process of flocculation occurring. Now, as those particles join together, and we can see here get a bit bigger, so now we have a big particle like this, and we've got another big particle like this. We call this flock, hence the name flocculation. Okay, and as a result of being larger, those particles are also heavier. And now, as a result of being heavier, they're able to sink, and as we can see here, being deposited on the seabed. So flocculation is a process which is actually used in lots of different industries, so things like the sewage treatment industry and the brewing industry as well. And we can see how it separates out that suspended sediment into this nice clear water with all of that sediment deposited at the bottom. So that's happening naturally within the water in an estuary because of that interaction of the salt water and fresh water.
Thank you for watching, guys. Don't forget to subscribe.